Hi, and welcome to Concept Based. I'm John Hepworth, and this is a new topic. This is year 11. We're inside the further work with functions part of your syllabus. We're on a specific part, and the part is called parametric form of a function or relation. So we're working with parametrics, which you may have never heard about before through your stage 5 syllabus. This is a new sort of concept of what's going on, but not new in terms of your reality. In terms of, we can think of a parameter of something like time, and we could talk about your car trip from a house to another house, and we could express how far you have gone in terms of time. We could say that time's the parameter that is affecting the distance of how far you've gone to a particular house. But how does that relate in terms of what's expected of us in our syllabus? So in our syllabus, we're looking at linear, quadratics, and circles and their parametric forms. Now, I'm skipping linear and just going with quadratics because the linear ones are quite straightforward, and I can explain just as much with a quadratic for you. So I'll do that. So I've got here a question. Given the parametric equations, x equals t minus 2 and y equals t squared on 2, graph the resultant function. Okay, so we're not used to seeing things like this. We're not used to seeing x in terms of t and y in terms of t. We're just used to seeing y in terms of x. Now we can do that, and that's what's required of us to do in this question. And the way we can do it is essentially we're sort of doing like simultaneous equations, and we're using the substitution method. We can just make t the subject in one of them, and then we can substitute it into the other one, and then we can go ahead and graph the function. But that's not all of what I want to do today. I have created a Desmos file, and I want to go through in Desmos what is actually happening with this parametric value. What is it? And how does it affect the point and what the graph looks like? So if you're a little bit struggling with these parametric equations and you want a conceptual understanding, here we are at concept based. So let's try and focus a little bit on that concept once we go through the mechanics of this question. All right, so the mechanics of this question are we need to essentially get y in terms of x. So one of our equations is x equals t minus 2. We're going to make t the subject, and so we're going to say x plus 2 equals t. Our other equation is y equals t squared on 2. So we now have t as the subject, and we're going to put that into this equation, and we're going to get y equals x plus 2 squared over 2. And we're now back in the land of what we're used to. We have a y function expressed in terms of x, and we're happy. We've been dealing with these since forever, year 8. And so this is a form we could go ahead and answer the question by graphing the resultant function. So it's pretty easy for extension 1 to have a question where you're just doing a substitution. But of course, it gets tricky. Not this question though. All right, so let's go and graph this. To graph this, well, first things first, to graph it, I might find the roots of the quadratic. So I'll set it to 0. And when we set it to 0, we can times the 2 off the bottom. We can take the square root, and we can see that the only 0 we've got is at -2. It's a double root. And we should remember that when it's a double root, that means a bounce off the x-axis, either in a positive way or a negative way. This is a happy parabola that we have, so it is going to be a bounce like this. All right, the next part, we really need a y-intercept. So we will expand. So y equals x squared plus 4x plus 4 all over 2. And then we get, ooh, I've got some graphs down here still. Y equals x squared on 2 plus 2x plus 2. So I've now got a y-intercept of 2. I've got an x-intercept of -2. And I can go ahead and graph my happy parabola, hitting at -2, going through y at 2, being a positive parabola. So we're coming in, hitting the x-axis. I missed the x-axis, but I'll make a blob and it looks like I hit it. And you get the resultant function graph like this. Okay, so that part's pretty easy. Make t the subject, sub it into the other function, go ahead and graph the function. But what is going on here? What do these parametric equations even really mean? Okay, well, let's jump into my Desmos file that I've made and have a look. So I've created a parameter here that is just t. So the parameter of t goes from -5 to +5. In the next line, I've got the x equation. So the x1 value is expressed as t minus 2, as it was in the original question. And I've got my y value, which is expressed as t squared over 2. So you can see that those both have values. Currently, at the value of the x is 2.58, and the y is 10.488. So the t value is giving me an x value, while the t value is giving me a y value. It's giving me two values at one time, which is essentially creating a point. So if I look at those points at separately, so let's look at what x does as t changes. So we can see the x value moves to the left as t moves to the left, it moves to the right as t moves to the right, but it's lagging it by 2 because it's t minus 2. Let's see what the y value does. The y value is going to go from 0 up and then back down to 0, from 0 back up. Okay, so it's positive. The y value is positive. All right, let's put those two together and see what happens with the point. So you can see now I've actually got the x point represented and the y value represented as a single point in blue. And when I hit the t function, the t parameter, and it varies, you can see the blue point now creates a parabola. It creates a curve. And in fact, it creates the curve that we defined earlier. It creates this y equals x plus 2 squared over 2. And there it is there, traveling along that curve exactly as expected. So let's go back a few steps again. What is going on here? Okay, so the idea is that we have a t value that is changing, and the t value is controlling the x value, and at simultaneously controlling the y value. So the t is the parameter that is controlling both, and we link both of those together, and that's what ends up giving us our function, our y in terms of x, which in this question ended up being a parabola that we were able to graph that looked just like this. Not exactly like the graph on Desmos. Desmos has done a much better job than me today, but as it should, because it is a fantastic calculator. I'll be doing more parametric equations, so keep an eye out for more videos coming up. I'll definitely be doing more difficult ones, and I really want to have a look at circles because circles really is something that students can rote learn. And as you know, at concept-based, I want to make sure you understand the concept of what's going on. And then later in these 2 weeks, we'll go on with some tricky HSC style questions.